Good morning. It's a beautiful day here in Sacramento. Hello, world. And today we are going to be working on these guys since they're now working. We are going to be working with them. We are going to be building effects. We're going to be tweaking the script and whatever else we can do in the next approximately hour or so. I don't have a whole lot of time today, but I wanted to do this yesterday and didn't. Some stuff came up, so now it's best time. So, if you came in last time and are unfamiliar with the proceedings here, basically how this works, here's what we've got so far. This is our script currently. We are working on an ESP32, doing an FFT in real time and serialing it over all the way into this beautiful series of numbers that we have here. So yeah, that's what's going on. Let me set this also up with a serial monitor input here. That'll be helpful. That guy. Oh, yeah, a little too helpful maybe. So let's do that and that, because that's really all we need to see, and preferably something like that, maybe. Yeah, and only when we need to see. So let's move me over. It's so beautiful. We have the technology to put things wherever. Oops. A little too much technology. Too much motion. Okay. But the point being is we have this whole series of numbers that are coming in instantaneously every minute, every moment of every minute. And we need to do something with them. So first step is in getting them to talk to the lights. We've already done all that. Right now it's just operating on taking the total value of all these numbers and adding them up right here. So we can, and then taking that number, that total number, it gets scaled to the appropriate height, and make sure it's not too big for a thing, and then draws the LEDs with the color in both the plus and the minus direction. So it's centered around the middle, as you can see. And I've tried to put it almost exactly in the middle. Depends on how you define middle of the closet, by the way. There are multiple middles depending on from what thing you are measuring. So the thing that looks like the middle may not be at the center of your particular architecture may differ. But the good news is that we have all these numbers coming in, and it's nice and snappy too. I've been optimizing this and splitting things into various files. So last time we had this net file, which deals with all our network code. And this time we have a whole sampling file where we've split out all of the FFT maths into its own system. Took a minute, but it's so much cleaner and more helpful to have all that over there, and you can just say include sampling, include net, include all these guys. So it helps. Anyway, what else we have? Stop me if I'm going too fast. All right. So we need to start. No, we need to finish. Yeah, we need to finish before we start. We need to finish the task of integrating all these bits with MQTT messaging, which will be a fantastic addition because then we can just signal directly from our wireless, because the entire device back here is just running on Wi-Fi. It's plugged into the wall and plugged into the main output of my system. So it's completely disconnected from the computer. It has nothing to do with so it's connected to the computer in the sense that I'm getting the serial information out of it, obviously, but we could disconnect that USB cable at any moment and the audio portion would still run just fine. And it's even being powered with the same power supply as the lights, so it doesn't need the USB connection at all to run. We're just using it for serial and debugging and for speedy uploads. So very handy with our ESP32 being Wi-Fi enabled. So let's take a look at that. I'm going to just take out this chunk here because we know what these numbers look like, and re-upload it. So now we'll clear this so we have a fresh slate. We have a hard reset, and in just a moment, any moment now. Okay, maybe a little too hard of a reset. There we go. Excellent. All right. So we booted up here, and then that was our first boot. We connected to the local Wi-Fi connected. We have our IP address. We got the current time because of the wonders of NTP. This is now. And we connected to our MQTT broker. So this is where we left off last time in our net file. So we've got this setup that does all these things here that you saw. We don't need, we do need that, yeah, for right now. Until we can start setting this up asynchronously, we have to wait for everything to be connected. So it takes a little bit of boot up time, but that is all right. My cursor here, right? Yeah, you can see all the, yeah, exactly. Okay, so connect to the MQTT server. In this case, it's Mosquito with two T's, Mosquito. And we set the callback. And this just tells it to keep running forever. on one of the cores, specifically core 0, on core number 0, where it ought to be running, which is on ESP32 where the Wi-Fi runs. So we are no longer suffering from the problem where the Wi-Fi is interfering with the FFT side. So we have wireless is running on its own and talking to the wireless. The FFT is running on its own on a separate core, and then in between those two, when in the main loop, whenever those other two tasks aren't running, our main loop has time to run and do all our LED signaling, because we don't really care about how quickly we can or do the LEDs, because that is by far the simpler of the tasks. So we can take a little time with that, because a slightly slower frame rate is still imperceptibly fast. So we have plenty of time to waste effectively and still not even look like it's lagging, because this looks like it's this is so fast for me. I'm not sure how the synchronization is. Hopefully the synchronization is everything. So if I were to clap in front of the microphone, hopefully if I've done my job right, that my hands coming together and the sound should have lined up at exactly the same time and gone with the lights. Hopefully, if that's all done right. The lights will be, by definition, a split second behind, because the audio has to get processed through our mixing board and everything, and then get processed separately through the ESP32 through our microcontroller. So it's technically arriving just a split second behind. The information is getting there just a split second later. But my perception, when I look at this, I see the lights going before I hear my voice. Like, I'm the one talking, and I can see. It's it's faster. It is faster than I am. Let's put it that way. It is faster. I can see what I'm saying before I can hear what I'm saying, is what I'm trying to say. It's wicked fast. It's beyond fast. It's like, imperceptibly fast. So we have time. Oh. And that point would have been so much more effective had my video been showing. Like now. Okay. Many separate systems, all trying to work in tandem. Oh, hello to whoever's checking out the stream today. Yeah, so we have got some IRA dev going finally. So we're just testing our synchronization levels and seeing how synchronized we can keep things. So currently, if I clap my hands, let's try this one more time. Caution, loud, sudden noises. If I clap my hands, the clap should appear at the same time as the sounds. Okay, let's try this. So I'm not sure how well that came across on video, but if nothing else, it'll be a test to see how far I have to set the specific video input delay, because that is a specific button, a very specific knob. Okay, but now that we've got this going, we have our setup done. We have light showing. We've set which pins we want on pins that don't interfere with the Wi-Fi, thankfully. And then we are coming in with these messages. So we've got the current time from the last time we rebooted. So now we need to deal with our Mqtt connection. So let's double check to make sure that we're still running. So if I were to send a different message, it sends. Although it's getting this and printing it in duplicate, which, is not the end of the world. I would rather have the message come through twice. So I sent a 4 here and it printed out a 4 twice, which might just be a printing error. So take it back to the printers. In the message callback. No. Callback. Message received on topic. Check. Serial print topic. Check. Message. Check. We are printing all the chars of the message in addition to printing the message itself. I think that's it. Let's try that. Re-upload, reset, redo, reuse, recycle, reboot. That was not the reboot button. That is the reboot button. Okay. Take 2. Connected, time. Great. And we're back up. Okay. And that really wasn't too bad. What was that, 3 or 4 seconds between reboot and actually running? So it got the 500 message. That's interesting because the last message we sent was 4. Let's check. So it's defaulting to that 500 number, even though I've sent it something else. 270, great, that's good. But now if I reboot that, does 500 come? 500. Oh, hey, thank you. What just happened? Thank you, follower. Whoever you are. I missed it. Thinking. Come on, show me who. Well, thank you for following. Give a shout out in the chat because I know I can see that. Thank you so much for following. This is just a little experiment that I'm doing, trying to get all this stuff working together in a way that is shareable with the rest of the world. So thank you so much for joining in. That's fantastic. Please find more about me in the thing and ask questions in the chat. But otherwise, I'm just going to keep going here and keep figuring this stuff out because it's complicated. It is very, very complicated. So we subscribe, we do the thing. A lot of this is, this is not. Yeah, this is a lot of temporary code. A lot of this is being refactored from examples online because it is so much easier to copy and paste from examples and refactor than it is, at least for me, to just start from scratch. The amount of mental energy it takes is vastly, vastly lower. Start from something that works, a working example. I've heard it said from people generations before me, make it and then make it better. So make it, have a working example, do the thing, save it, put it away. In this case, git commit it and throw it in the cloud and then make it better. So yeah, That is the process. That was what we were trying to do. Hopefully with at least a little success. I mean, obviously, because these things are working, and they weren't working many times in this last week. Many times they were not working. Okay. So speaking of committing that, let's see. What of that did we want to commit? Oh, just that. Okay. That's just the one line, so that's fine. Because the rest of this stuff, yeah, there's some other code that is not committed, but I just need to go through it all because we're assembling all the pieces of our baked good, our cake, our pie, our dinner, whatever you're feeling hungry for. So we need all the pieces together, and we have many of the pieces. We have the hardware, we have the circuit, we have the signal, we have the split cores, we have the network, and now we need the messaging protocol. So we need, no, I keep going there. We need, in this callback, this is our big action. So one thing at a time, we could action it this way. Because we have a string that says our messaging topic. So right now we just have, yeah, so let's set up, since we need to have some sort of messaging structure. It's not, I mean, we have the messages coming in, which is fantastic. The getting the messages to their destination from literally just from a Wi-Fi client from my phone. So cool. So now okay, now let's do this. And there we go. Ah, the Lone Ranger. That's who it is. Thank you so much. Appreciate the follow. Okay. So now that my devices are maybe, so I guess that one's just not refreshing. Oh well. This is why we test. This is why we experiment. This is why we dev. There it is, the Lone Ranger. I can now see it in my line of sight. Okay. And again, feel free to shout out in the chat. Happy to answer questions and things, because I don't know everything and I'm making this up as I go. Just like everyone else. Okay. So we need to deal with this, but also the point of this, dealing with this, is to integrate it with the other effects library that we already have written. That we have written from, well, I mean, what is from scratch, really, I guess. I wrote some of the effects from scratch, but I only could do that because I copied and pasted the other effects and rewrote them better and then understood the process well enough. So it's the age-old, there is nothing new under the sun. So much of this has already been done, and it's just more a matter of looking for the proper index. And Google will get you 99% of the way there if you just ask. Okay. Let's start by just switching between these two effects. So our message, so we have one effect going and we want to be able to signal another effect. We're still in the proof of concept mode right now. So we're on the LEDs channel of our message broker. So we want this to be FX. And the specific effect we need to check in our core code. Okay, so this is not so much. So this is we're using this as our loop right now, but this is not really the loop. This is really our effect, our FFT effect. FFT center, FFT. This right here is the second hardest problem in computer science, according to Mr. Donald Knuth, who knows a thing or two about difficulty in computer science. The most difficult thing is cache invalidation, and the second most difficult thing is naming things. So we are on that second one, and fortunately we don't have to deal with the first one today. Although it is technically happening, although just at a much, much, much faster rate than we care about. So we don't have to care about that. So we won't. FFT effects, FFT. It's not just the FFT. This is FFT bars. But it's the reflected centered bar, the plus and minus around 0, as opposed to middle bar, centered bar, mirrored bar, FFT mirrored. Yes, that is the correct way to spell that word. Mirrored. I feel like I'm in an episode of The Rural Juror where they mirrored their pronunciation. Mirrored bars. That one I do know how to spell. Okay. Don't need that anymore. Okay, and now, because that is an effect, we can just grab all of that and add a new file, new tab called fx.h, because everything is a .h, because I don't need to split things yet. So for now, everything's just in the .h, even though one is supposed to, I know, do the .h.cpp, put the code in with the headers, but we're getting there. We're building our way. We are working on it. All right. So now okay. Still looking good. So now we actually need a real loop. That will need to decide how to deal with what effect to be running, because we can assume the FFT is always going to be running. So that's always running. And the Wi-Fi is always running because we've pinned those to their relative cores. They are pinned. So we just need to actually signal the thing. We just need to say go through and do the effect. It would be nice to have like the time and stuff printed, but let's not deal with that now. Because this is going to fail for several reasons. So let's just see in what ways it fails and fix those, because we're going to need fast LED over there. Oh, did we? Okay, we've been breaking things. Oh, because we uncommented all of that. So let's double uncomment or double comment that and then that. Great. Okay. Course to do is not declared in the scope. Yes, because we did not include fx.h, and we'll need to move that over here because this is where all our LED maths are going, and we need all our setup stuff, and we need that, and we need those. So yeah, we just need all of it. And maybe, hopefully, we'll see how we do. Is that enough? Is that enough to get by? That might be enough. That might be enough. That was enough. That did it. Very important to celebrate victories like that. We win. Thanks, Mom. Upload. And hopefully that doesn't break our existing anything, but we're going to find out. Clear that. Reboot. Good. 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 We didn't break anything. Excellent. Let's just go and put some of those changes in there. We don't care about that really, not yet. We want that and all of that. I guess I could show what's going on here. So if you have not seen before, this is my favorite way to commit, to get, commit and to get. We don't that. So unstaged changes here, things we don't care about, things works in progress. line by line deletions, insertions. So what we did, we don't want to stage that. So it's a little buggy sometimes. I have to unload and reload, but this is Atom, ATOM, Atom. Open source browser, extremely hackable, lots of plugins, lots of extensions, cross-platform, does all the things. Even has a very nice sharing function if you are coding with someone, especially if they are not in the same room as you. You can just share your whole file with them and they can edit it right in front of your face, and you guys can work on it, or girls or anyone can work on it together. You peoples can work on it in simultaneous tandem without having to move things to Google Docs. Very convenient. So anyway, we deleted all this stuff and just said include fx.h. Look at that. Look at that. Bye-bye all that. Just straight up move that into fx.h. Just copy paste that into fx.h. And all of that, and that got replaced with that. So yeah, that's enough to commit that. And I guess that's just a, not, well, yeah, that was just a 1 exclamation mark. That's worth an exclamation mark. But just one. Okay. Committed. Oh, and now we push, pushing, pushed. Okay, we've made it. Now we can make it better. I think I have one more round before I have to get going. But nope, holophoner is not on. I don't have a drum kit. Close enough. At least these guys know what I'm talking about, right? Am I right? Okay. Doing good. That's progress. This was originally a like 300 line plus file, and we've now split it into 1, 2, 3, 4, 5, 6 files. So now that we've split the FX into the FX, and so our core is just now calling the effect, now we need to decide what to do based on, so we need to hold the state of whatever effect we're doing. We need to hold that globally somewhere, because that's going to get changed from time to time by a process running in a completely different thread. So that will need to our message will need to wait, because we have our message. Oh no, message is our payload. That's the payload, and the topic is our channel. Okay, I need to get my terminology straight from excuse me, other messaging brokers. So we have messages arriving on this topic, and the topic will need So yeah. So we're just going to change topic here because this is where we need to refactor this code into stuff that we do. Oh no, we need to keep that topic exactly like it is because that's a callback. And then we need to overwrite that into some sort of global buffer that could be in the effect. So, and this is also the phase at which it becomes important to look at the code that I will be integrating with this that I've already written years ago and have completely forgotten exactly how it works, to figure out exactly how it works, because that's kind of like these two steps are kind of one. Like they're the same thing, even though they're different. But yeah, I need to make it better. I need to have a some kind of way of having that information because, okay, so I guess I do remember it a little bit. Let's go for just a second to the code. Oh, it's on Atom. I can just do it there. Let's look it up locally since it's all stored locally. Oh, unless my branch is not right. Okay, I'm getting ahead of myself. I said stop me if I'm getting ahead of myself. So let's not get ahead of ourselves. IRA. No, IRA? Huh. Okay. I stand corrected. I guess we will go to the gits. Okay. That should be good. All right. So here, yeah, this is not the branch I want, I don't think. Although, so that, maybe it is. November 10th. Wait. Okay, so I definitely started down this path. Wow, that was only a year ago. Huh, seems like so much longer. Seems like this was the last kind of time that I dealt with it. Anyway, not the point. So I guess, yeah, I guess this is what I want. In the generator, in the... Oh, is this where? No. Oh, I split the readmes. That's what I did. That's why it's not a ginormous readme. Okay, so here's how we did it before. Points to pass me for documenting. Oh, thank you, GitHub. Thank you, GitHub, for that. How long has that been? Can't you just hear the that? I don't know why it's a but is it a pleasant hiss is not the right word. It's a pleasant sizzle of copying. That is the sound of my bones not rushing to jump to Control-C. Just a little. 1 second. Dealing with my gig later today. Okay, sorry about that. Just dealing with my gig that I actually have today. So nice to have something going on. All right. Let's see. We want to take all of this. Nope, not that. Not that. All of this. And so previously on IRA development from 2 years ago. Is that it? Oh no, the development, the creation was 2 or 3 years ago, and maintenance was 2 years ago. No, it was 3 years ago, yeah. We want the generator. So that is all done with a master color. And uint 8s, because we wrote that specific to the DMX protocol. Here we go. Let's share this, since this is what I'm looking at. So many buttons, so many screens. Oh, but I do have buttons for that here. Yes. Please? Oh, do I not have... Oh, it does this every time. I don't have those buttons. I have broken buttons. I need to fix those buttons, which requires a restart, which I'm not going to do right now. Okay, we are just going to keep going and close this out. So these guys were written specifically for DMX. And here's all our effects in this. Oh, look at that. Look at this 400-line file that I wrote. Oh me. Oh me. Anyway. Okay. If news. Because that's... Oh, yeah, just if things have changed. Just a change flag that I should have put up there. Oh, no, because that other people... Yeah. Synchronous, asynchronous coding. I remember this now. But very robust in real world settings, very robust signaling. If you have a well-defined messaging space, which we did, a very well-defined messaging space and an extremely well-defined FX space and vocabulary. Yeah, and the great news is that we don't have to, not only did we have to do things this way, but we also had to do things, well, maybe that is in there. Of course, in the rest of this 400 file, 400 lines, it's the on serial. Yeah, there's our little flag. But a nice little, if all you have is a serial connection, then just take it and do it. Oh yeah, this is all from the packet serial library. I remember that. I remember it well. So, yeah, P serial, good fun. Yeah, so we... Why did we do that? Oh, I remember, because there is no promise that the lock will... Yeah, that is done. That is a dirty semaphore lock. So the DMX buffer can change, and only when, I think, or maybe it's just duplicate. It might just be duplicate. So the more I'm looking at this code, the more I think it might be less of copy and paste and more of actually refactoring it, because all these effects, because all the effects now can have local variables, and moreover should have local variables, and the only things that are global are going to be things like the size of the LED and the chipset and stuff like that, stuff that is set because it's physically set. Everything else, according to the effect, because the goal here is to... So we have the MQTT part. We have our effects running individually. Yeah, I guess we can't really do this until we solve... Yeah, we have to add the engine in next. Yeah, that's the next step. So that's going to be a little more involved. We need to swap out our engine, because right now... Sorry, more gig things. Okay. Again, thanks for the patience. Got stuff going on, but I wanted to share a bit of this and how it works under the hood. Because that's the cool thing about open source is here it is. It's all public information. And the only thing that's standing in the way between me and it is understanding what it is, what it does, and how it works. All solvable problems in the grand scheme of things. Absolutely. All right. So, yeah, we already refactored some of this for ESP32, but yeah, that's what we tried to do with the API.h. I'm not even sure what was wrong, but it actually honestly might have been the pin number now that I think about it. Because that would be the very first thing I would check, because that was many, many, many hours of wrong stuff that I started with. Yeah. So, what does that mean for us today? What can we do with the couple minutes that we have left? Well, let's see. Starting from here. Starting from here. What do we need to do here? So maybe just right now. No, that needs to happen in the loop. Yeah, that needs to happen in the main loop. It needs to be able to check. I mean, we might be able to write this into its own loop and pin it to the core so that our loop is empty. So then we'd have, 4 things running independently, maybe? The Wi-Fi, the FFT, the LED, and the master central controller that decides the effects engine. Wow, this is complicated. Yeah, well, thank you, I presume the Lone Ranger, for sticking it out with me through figuring this stuff out, because, yeah, there's a lot going on, and this is so much more than just a example sketch, because the goal here is for it to be working in a production setting, and production environments are hard. There's a lot that can go wrong. There's a lot of circumstances, and you have to account for all of them, because program crashes are not good at this scale and this level. We want this running all the time. We want this running, hopefully a bunch of these running simultaneously, because they're so cheap to make. So we want them to be fully functional and reliable, and reliability is really hard. All the extra nines of engineering is really hard. But for easy, everyone would be doing it. Okay, so first off, one thing we can do for sure is take these guys and, well, no, these need to be here. No, can't move those. But it's fine for them to be here. And we could, if we wanted to, split out every effect into its own file. Yeah, so splitting this into multiple effects files. So maybe these guys need to be in the pins file, in which case we would import it. Are we even using brightness, or did I get rid of that? We're not even using that. Let's get rid of that. And we're not using that, so let's get rid of that. And we want these defines. I think that's okay for them to be in pins, but we might want to rename pins to config. Let's try that. Rename config.h. Excuse me, I hear a mewing. Someone wishes to make an appearance. Or not. Okay. And so pins is now config, and we need to include that. In FX. And we'll check that we haven't broken anything yet, which we did. Oh, so that does not find, oh, search all sketch tabs. That's the only place where we find it, which we don't want brightness, because we don't use brightness on a global scale, certainly not for, well, except we might. So what is fast LED set brightness? What is it? 100. What's the scale factor? Uint 8, 0 to 255. Oh, so that's 100? Huh. Still pretty bright. Okay, good to know. But ideally, we would want that. Oh no, we can still do that anywhere. It just affects everything running. So when we have multiple effects running in our effects engine, it will affect all of them, which is good that way. Okay, so I guess we do need brightness. Fine. Config. Oops. Nope. Brightness. Brightness. Okay. Master brightness. Great. Great. So now if we refresh, everyone's happy? Are we happy? Are we cool? Are we? Are we happy? It says done compiling, so that means we are happy. Okay. I accept this level of happiness. All right. Okay. And I guess these... No, those are all specific to sampling. They can live there. That's fine. Yeah, that needs that. That needs that. Yeah. Okay. So we do need to, for right now, have something. Right, because the FFT, we want the FFT to go fully. We don't want it to stop in the middle. We want, well, that would be okay if this failed in the middle, right? Because then it just wouldn't get too fast LED show. So the question is, do we, in our architecture, do we want the effect to finish, or do we want to interrupt the effect? Because one, on the surface, it sounds like if we interrupt the effect, it will go faster. But that can also lead to adverse consequences, because it might actually make the next effect appear slower and appear like there's a little lag, because it might be somewhere in the signaling or somewhere in the math process and churn through the most of its work, but not actually get to signaling the lights yet, and then be interrupted and have to do something else and calculate something differently, and so wait potentially another frame. And it all comes down to, yeah, I guess it really does come down to the animation engine kind of takes over at this point. So we need to, I guess we need to start integrating the animation engine. Like I keep trying to put it off because it's complicated. And the messaging broker stuff is so much more fun because you can actually demo that. And without, because otherwise it's just going to look like this for a while unless I break it or until I get something else running. I mean, we could do something else basic. Well, yeah, what if we maybe just wrote out, okay, let's do this. We have our mirrored bars effect. In the spirit of make it better, here is what we're going to do. We are going to have a little bit of that coming in from the net. And this bit that we uncommented, the action bit, so instead of that, we are going to set some string, some global string, and global can be here global. We want a string called, naming things every time. We want a string called FX, because that's the current effect. Semicolon. I always forget semicolons because I learned Python first. And I did not think one needed semicolons, so I always forget them. So if you ever see a missing semicolon, please let me know. Anyway, here we want to make that fx string equal to message temp semicolon. And in the here, since we've already included that, we have just a nice simple little if fx equals no, that's not what we want. That's half of what we want. But this fx will probably need to, no, this is a temporary effect variable. Should I call it temp? No. Will it get committed into the code accidentally and then become a permanent part of the architecture? Probably. But I also have a gig to get to, and I want to finish this up. So that's what we're going to do. So here we go. So it's not the fx. The fx is going to be the topic, and or should we just call this topic to make it less confusing? Topic and message equals message temp string oh, that's nope, that's a string topic and an int fx, because they're all ints right now, and it's bigger than a uint8, so it's just an int. Good. Oh, and this line. Cannot tell you how much consternation came from that line. It actually wasn't that much, but it felt like a lot at the time. Okay. If no longer fx, but if topic equals and in double quotes, because again, we're not in Toto, we're not in Python anymore. If topic equals LED slash no, because that has to do with the, no, we really do want this to be fx. Current effect. Because that... Oh, yeah, we do want that to be effect. fx and message, int message. Okay. Yeah, why didn't you catch that? One viewer. Lone Ranger. Do you have a Toto? Or Tonto, I'm sorry. Do you have a Tonto? That is my question. Feel free to chat. What do we want to do to make sure that, so not that, so fx okay, I think I got it now. So here, these uncommented lines, and that one too. If string topic equals LEDs fx, that's where we want it. Then no longer this one, but fx, global fx equals message. To string, probably. So that will tell us which one to do. And we're going to have another one. These, that's if string topic equals lead slash, this one's going to be called delay. It was formerly called speed, and that was not what it was. It was anti-speed. So we are going to call that, oh, we can't call it delay. That's no, we cannot do that. LED delay? LED delay, or should we just capitalize it? Maybe just that. So that's in there. And the delay, the speed. Oh, it's not in here. We need to add a new effect. We need to add a second effect from which to choose in this sketch, because we only have the one effect. I thought we had that, but that is in another sketch. That is in Mqtt test. Yeah, that's where this all comes from. To int message to, oh no, so it's not toString. I unnecessarily stringified. It's not message. Topic. No, it is. It is the message. Message temp to string. Yeah, that should compile, yeah? No. Class string has no members named toString. Message temp is a string. It's message temp. Okay. String the string. I want you to take this string, make it a string. What kind of string do I get? It's a string. It's still a string. Lead delay was not declared. Yes, you are correct. because that is a parameter of a thing that we don't have. So we're just gonna, again, we're gonna make it, and then we're gonna make it better. Recompile. Baby steps. Baby steps. And then we need to get going. If fx equals, and it's not LEDs anymore, it's just going to be FFT. Then we do that. LF. LSF. Fx equals good old Cylon. Okay, now we just need the Cylon. That's not defined. That's going to fail. Because we need to copy our Cylon. Oh, Cylon or new Cylon? New Cylon. New Cylon. New Cylon from the old script. And yeah, for right now, I'm going to put that in the FX sketch because they share the fast LED library. But this right here is probably the moment where it would be wise to split it into a CPP file where the effect goes in the fx.cpp and all the definitions go into the H, because then our imports won't be weird. Or includes, excuse me. My Python is showing. So this is just going to be Cylon. We know you're new Cylon, but you're just regular Cylon here. You're a new Cylon in a different pond. And you need some variables. Do you have lead count? You have num LEDs. So we're going to give you num LEDs. Around these parts, we call it num LEDs. And U2. And then we just need these guys. We need pixel, which is a... Oh, is that defined in the .h? Did I... Was this like when I just started to do that? Nope. Nope, not quite. What is pixel? Oh, CRGB pixel. Wait. I don't need to... Oh, so pixel is... What? For inside the 4 CRGB and position. Yeah. So okay. So pixels defined there. Okay. We need our POS. Int POS. We don't want it there. We want it just outside, but I'll keep it right next to it. So we have our POS, our global position. We need an I size, which for us is a uint here, but we really just want that an int because who knows how big this could be. Could be bigger than a uint. Oh, and even in previous times, that could be bigger than a uint. No, because I could only signal it up to a uint 8. Do we need an arg? We don't need an arg. Position, num LEDs, and color. We need color. We need a CRGB color. And we are going to default it not to black. To 2. And maybe that's enough. LED, LED. Oh. Yeah, that's not defined there because that does things differently. We do things differently around these parts. Interesting. Well, LED. Because in the sampling, it just says fat. Oh no, in the effect, it says fast LED go. Oh, LEDs. There you go. Already defined. LEDs, 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 LEDs. LEDs cannot be used as a function. Okay. Well, that might be where I have to call it for right now because I need to get going to my gig. But aside from, and I'm sorry I have to end it on something that doesn't work quite yet. That's probably just a line or two away from, oh, we need this hue speed here. We're going to need that. I know I can fix that, but I'm not sure I can fix the calling of the thing as the function because that's a shorthand for how I did it. But we could real quick. CHSV, of course, because it's a CHSV. That's fine, that's fine. But it's still going to complain. Oh, missing semicolon again. Okay, so instead of that, can we say for int I equals 0, I is less than num LEDs I plus plus, then that it's not the pixel now, it's now LEDs I. So is that cool? That's cool. Okay, that's cool. That's cool. So that's but it's not that. We want to start at I equals position I less than position plus I size. Plus I size. And I would love to explain all this, but I would also love to remember all this. This is a time efficient, frame by frame of the Cylon effect, or just a variable width moving dot, moving line, moving bar at a variable speed. For this is gonna be int I equals 0. I is less than position plus I size mod num leds semicolon I plus plus, no semicolon, but an open bracket. Is that okay? Is that cool? Yes, that's cool. All right, one more, and maybe we end on a high note. He's a good pixel for int I equals position semicolon I is less than leds I plus plus, no semicolon, but open the bracket. Hola termina. Oh, not quite. Because pixel is not defined, because we need to set that to leds I in both cases. Leds I and leds I. Hola termina. Void loop doesn't. Oh boy. Okay. A function definition is not allowed here before that. Huh? What do you mean? What if that's exactly where I need to make the function definition? What did I do? What broke? Did adding of that stuff really break it? Yeah? Wait a second. Oh, because I'm missing a bracket, obviously. Okay, hola termina. Last call. Done compiling. Upload. This might be it. This could be it. Then I really have to go. Writing. Hard reset. Check. I feel like we're taking off for launch here. Here we go. Okay, we did not break. We did not break. Okay, here we go. Here we go. Okay, here's our message. Let's FX message is gonna be FFT. So this should bring us back to where we were. 1, 2. 1, 2, check. Message not arrived. Message arrived to Mqtt. But it's still listening, so we just have something wrong. Yeah, I really need to get going. But it's so close. It's so close. I can't. This is coding. This is what it is. This is how it works. This is what we do every single time. Because I say it's going to take an hour, and then it takes an hour and a half or 2 hours. Oh yeah, no, I have to get going. This is no longer acceptable. Okay. Okay. Is it in the callback? Yeah. If string topic equals Led's effects, then that equals message. Wait, did that not get uploaded? Is that still running the old code? Because it received, wait, message arrived on topic. Oh. Byte message. That should be okay, because it's the topic that gets turned into a string. No, the topic is a string. It's a char. It's a bunch of chars. String message temp. So yeah, on topic loops, lead speed. So why did not message arrive on topic? Fft. So it should be there. Do I need to string it? No. Well, that really should have worked. But it's not getting in. It's getting in for the message loop speed. Let's try to upload one more time. Maybe it just did not upload. Why is it getting that LED's loop speed message? That is so strange. I'm sending the FFT message, but it's not coming in. Loop speed has no problem. Every single time, yeah. Okay, well, it's a bug, and I gotta go. So thank you so much for joining me. I presume the Lone Ranger, Tech Lone Ranger, if that is your real name, which I sincerely doubt it is not. Still waiting on an answer if you are, if you have a Tonto. Just message me. I'm Harpo. Please support me if you like this. If you want to see more of it, because it's really difficult to do. Even though we started with more things than we ended with a broken system. It is more powerful than it was before. So that's good news. All right, I gotta go. Thank you so much. Bye-bye.